Hey everyone, Mrs. Martin here, ready to talk about exponential function. It is pretty common knowledge that rabbits reproduce very quickly, so let's look at an example of that in this exponential problem. We'll start with the table, where we've got months versus total number of rabbits. Notice I included total here so I can get a good view of a pattern. We'll begin with 0 because that's our starting value, a point where no time has passed. Now let's look at the first month. We've got the 400 from before, and then a 20% increase. I get this 20% increase by multiplying by 0.20. And I get that 0.20 from the 20% rate of increase. Now let's look at 2 months. Again, I've got the 480 from previous value, 480 times 0.20 to get that 20% of the population. And that's all great, but what happens when I have 12 months? It's kind of inconvenient to just keep going in this manner. So let's go back and look at this a different way. Notice these 400s. We can factor them out. Notice that now that I've factored, I can simplify, and this is much nicer. But it's still recursive because we're relying on the previous value. Let's keep going and see if we can't find a pattern. We'll take the 480 from the previous month and multiply it by 120 again. But this time, let's replace the 480 with the 400 times 1.20. After substituting this, we might notice that now we have two 1.20s. And if we use our knowledge of exponents, we can rewrite this. Let's keep this process going for one more month, replacing the 576 with 400 times 1.20 squared. And again, you might notice that when I simplify these, I can once again use my knowledge of exponents to change that to 1.20 to the third power. Now things are starting to look a little crazy, so let's take this important stuff and put it in a new table. So once again, I've got my months versus total number of rabbits. And I'm going to include those important components of that last table. As we move along, try to see if you notice any patterns. In our last table, this is actually 691.2. But since we're talking rabbits, I'm going to round. Notice any patterns? If you look carefully, you might find that the exponents match the number of months. But what about 1? Well, there's technically a 1 in that exponent. How about 0? We can rewrite 0 to have a 0 power. Remember, anything to the 0 power is just equal to 1. And so now we can start creating a general formula for some unknown number of months. So we can write 1.20 to the nth power. Notice also that 400 is in each of these expressions, so I can include it in my general expression here for n. And that 400 is coming from our starting value. As for the 1.20, we find that from the 20% each month. And we can write a general expression for this scenario. Here's a graph. That's a lot of bunnies. In conclusion, when we're looking at exponential models such as these, there's a pattern. Our general form is y equals a times b to the x power, where a is our starting value and B is our pattern of multiplication. Thanks for tuning in.